Uh, Good morning. Welcome back to our channel where we will be solving maths problems for different levels. So today we are going to be concentrating on a problem on analytical geometry, grade 11, from the paper which was written in November 2017. That is question 3 and question 4. So we are given question 3 here. A, which is having coordinates -2, -5, B, C, and D are the vertices of a quadrilateral. We are given the vertices of a quadrilateral A, B, C, D, such that diagonal AC is perpendicular to diagonal BD at T here. Then the equation of BTD, which is one diagonal, is given by 2y plus x equal to 18. And AB, we are given its 15 units. Then when we go to the question, it's saying determine the gradient of line AC. If we are to check that line AC, you are told is perpendicular to this diagonal BD. And we know that for perpendicular lines, the gradients of perpendicular lines are negative reciprocals. So we need to determine the gradient of BD, but in this case we are given the equation. So to answer that, it means we need to rearrange the equation of line BD to be the gradient intercept form. So we are given that BD, the equation is given as 2y equal to 80. We take the x to that side because we have to arrange it in gradient intercept form. So it means the x must come here. So it's going to be negative x plus 18. Then we divide throughout by 2. So y will be equal to minus 1 over 2x plus 18 divided by 2, which is going to give us a 9. That is the equation of this line when arranged in gradient intercept form. So we can therefore conclude that the gradient, which is denoted by M, the gradient of the line BTD, that diagonal BD, the gradient of diagonal BD is equal to the coefficient here of x, which is -half. Then, since we know the relationship between perpendicular lines, it means therefore the gradient of AC is equal to 2, which is the negative reciprocal of this one. What is the reason for that? Because we know that BD is perpendicular to AC. And we know that for perpendicular lines, their gradients must be negative reciprocals. So then the next question is saying determine the equation of AC in the form. So AC is a straight line. To get the equation of a straight line, we need gradient, which we just calculated, and a point, which we are given there, the point at A. So it means our y is equal to mx plus c, but our m, we already established that the m of gradient of A is 2. So 2x plus c. Then we need a point to determine the value of c. So the point, we are going to take the point that we are given, the point of A there. So it means where there is y, we are going to substitute a negative 5. This is 3.2. We are going to substitute a negative 5 being equal to 2. Where there is x there, we are going to put a negative 2 plus c. So the negative 5 is equal to negative 4 plus the c. Then when you do the transposing, this cos there becomes a positive. So it means the c is minus 5 plus 4. So it becomes minus 1 equal to c. Eventually, we write the equation in the standard form. So it's going to be y equal to 2x minus 1. This becomes our equation. Alternatively, we can use the format which says that y minus y1 must be equal to m multiplied by x minus x1. Then the y1 is representing the y coordinate of the point that we know. So it's going to be y minus the y coordinate that we know is minus 5. Then we close that. That must be equal to m, the gradient of the line AC, which we determined to be 2 here. Then our x, then minus the x coordinate of the point that we are using, which is minus 2 there. So we are left with y plus 5 minus minus must be equal to 2 open bracket x plus 2. Then when you simplify, the y will be equal to this times this. We are going to get the 2x. This times this plus 4. Then because we take away this 5, when we take it to that side, it's going to be minus 5. So y is equal to 2x minus 1. Then the next question is saying that 3.3. If AC is equal to 2x minus is y equal to 2x minus 1, calculate the coordinates of t, which coordinates of t is the point of intersection of these two diagonals, and we have the two diagonals. So it means we have to solve the two equations simultaneously. The equation of the other diagonal, we are given it as 2y equal plus x equal to 18. Then the other diagonal, you are given it as y equal to 2x minus 1. This is our equation 1. This is our equation 2. So it means we can substitute our equation, that is by using the substitution method, we can substitute equation 2 in 1. So wherever there is y in 1, we put 2x minus 1. So it therefore means that we are going to have 2, my pen. We are going to have 2, where there is y, we are going to substitute 2x minus 1. Then we are having plus x being equated to 18. So when we simplify that, we are going to have 4x minus 2 plus x being equated to 18. And then the other one is going to be, when we simplify this, combining the like terms, 4x plus x, we get 5x equal to 18. Take the other point to that side, the other term, which is minus 2, it becomes plus 2 there, so it's equal to 20. Divide both sides by 5, so the x is equal to 4. When we get the x equal to 4, we substitute that in this any of these equations. So if we are to substitute in equation 2, it means our y will be equal to 2. Then where there is x, we now put 4 minus 1. Simplifying that, 2 times 4, it's giving 8 minus 1, 7. So it means the y value is equal to 7. Therefore, the coordinates of t can now be given as 4, 7. Then, if ABCD is a kite with AB equal to BC, meaning to say, in that question we are given that this will be AB will be equal to BC. They are now determine the coordinates. Determine the coordinates of C. To get the coordinates of C, okay, let us erase what we have now, so that let us erase this part. We just want to erase this side. So we are going to answer question 3.4.1. Bear in mind, it is already established. It is already established that the coordinates of these are 4, 7. We know that T is the midpoint of AC. T is the midpoint of AC. That is question 3.4.1. T is midpoint of AC. What's the reason for that? For a kite, it means that BD bisects AC. BD is bisecting AC. The longer diagonal of a kite bisects. The other diagonal of a kite bisects the other one. So using that, we use midpoint formula. We know x coordinate at midpoint must be equal to x at one point plus x at the other point divided by 2. So in this case, the x at midpoint, we know it to be 4. So that 4 must be equal. The other endpoint is this a, which is minus 2, plus the one that we do not know there, which is at C there. the x-coordinate as c divided by 2. When you cross multiply here, we are going to be left because this is over 1. So when you cross multiply, solving the equation, we are going to be left with 8 being equal to a negative 2 positive that x-coordinate at c. So conclusively, the x at that point c will be equal to 10 when you add there. Then the y part, we know the y at midpoint must be equal to y at one endpoint plus y at the other endpoint divided by 2. Here, the y at the midpoint is 7, which is equal to the y at the other point, which is negative 5, plus the y at c there, divided by 2. When we cross multiply, we are having 14 equal to negative 5 plus y at c, because this one is over 1. So when we cross multiply there, so eventually, when we add there, it means that y at c will be equal to 19 after adding a 14 and a 5. So the coordinates of c are going to be given by 10, 19. Then, in the next question, which is is 3.4.2. They are saying calculate the length of BT, but if this is BT, but if you check here, we are having 90 degrees. That's our BT here. If we are to check here, we are having 90 degrees there, which is given. Then this side, we are told is 15. Then we can calculate the length of AT using distance formula. So from there, we can say the length of AT is equal to the square root of, using the distance formula, so it's x2 minus x1 squared plus y2 minus y1 squared there. So it means our AT, we can use distance formula since we know the coordinates of A and we know the coordinates of T. Then that one becomes the square root of, so it's gonna be 4 minus 2 squared plus, there is 7 minus 5 squared. So if we check here, it's gonna be 36 or 6 squared. If you check there, it's gonna be 124 for 144 for 12 squared. So it means it's root 180. It's root 180. Then root 180, it can be written as 6 root 5, the simplest said form. Or let's leave it as root 180. So it means this is equal to square root of 180 units. But since we now have this one, which is root 180, the question wants us to get this. So it means we are going to apply the Pythagoras theorem, since in triangle ATB we have a right angle So applying Pythagoras theorem, it means the hypotenuse squared, which is 15 squared, must be equal to the other side squared, root 180 squared, plus that other side, which is BT squared. If we are to simplify here, it becomes 225 minus 180 must be equal to BT squared. Then simplifying this, it's 45 being equal to BT squared. When we find the square root both sides, we are not going to put plus or minus because we are dealing with the distance. It therefore means that BT must be equal to 3 root 5. Then it's saying write down the length of the radius of a circle passing through B, B, C, T, B, C, T. If we are to see, they say write down the radius of a circle passing through these points B, C, T. So if we are to check, if we are to put a circle passing through these points, circle passing through BCT, we can conclude here, since we already know here it's 90 degrees, we can conclude that therefore BC must be diameter of the circle. So in other words, we are going to answer question 3.4.3 because this angle is 90 degrees. We can therefore conclude that BC is diameter. Why are we saying BC is diameter? It's the converse of angle in a semicircle. So if BC is diameter, the question wants you to calculate the radius. So to calculate the radius, we know radius, it's half of diameter. We know the radius is equal to half of diameter. And here our diameter, since you are given that this side is equal to this side, so it means here our diameter, which is BC, is 15. Therefore, radius will be equal to 15 divided by 2 units. And please take note for this one, let's not forget to put the units. We are now on question 4. You are given C, a point on the x-axis, A minus 5 minus 3, and B, 4, 12 are the vertices of a triangle. AB intersects the x-axis at E. You are given ABC as theta and BAC as alpha. The first question is saying calculate the gradient of AB. If we check, we are given the coordinates of A, we are given the coordinates of B. So then you are required to calculate the gradient. So It means gradient of AB for question 4.1. We are going to copy the gradient formula. Gradient is equal to y2 minus y1 over x2 minus x1. So if you decide this set of coordinates to be your 2 and this one to be your 1, it means this one becomes your y2, this one is your x2, this one is your y2, this one is the x2. So it means the gradient will be equal to 12 minus 3 over 4 minus minus 5. So we'd realize that this is giving 15 divided by 9, which is equal to 4 is equal to 5 over 3 as the gradient. Or if you decide to take these ones as your ones, this one as your twos, it means x2, y2, x1, y1. It means the gradient using that same formula, it was going to be minus 3 minus 12 divided by minus 5 minus 4. So this was going to be equal to minus 15 over minus 9. The answer is still going to 5 over 3. Then the second one is saying determine the coordinates of point E. And point E, we are told that it's the x-intercept of A, B. So it means we need the gradient, we need the equation of AB. So to get the equation of AB, so it's y minus y1 equal to m open bracket x minus x1. This is the equation. So when we substitute the equation, we know our gradient, we got it there. Then our point, we choose either A or B. So if we are to choose A, it means it's going to be y minus our y1. It's a negative 3, which is equal to m which is equal to 5 over 3, open bracket, we have x minus 5 there. Now, we want what on this equation? We are told this is x-intercept. So for us to get the x-intercept, we are going to substitute y equal to 0. So putting that 0 there, it means it's going to be 0 minus 3. We are left with 3 being equal to 5 over 3, open bracket, x plus 5. Then dividing both sides by 5 over 3. If we divide both sides by 5 over 3 here, you come and divide by 5 over 3. There you come and divide by 5 over 3. It means here we are going to be left with 9 over 5 being equal to x plus 5. When you subtract the 5 both sides, when you subtract the 5 both sides, it means the x is gonna be 9 over 5 minus 5. So the x there is gonna be equal to minus 16 over 5. Therefore, the question wants the coordinates. We can now write the coordinates of E as minus 16 over 5, then 0 as the y coordinate. And take note, if we had used the other point there, or let's use the same point but using an alternative form of the equation, let's use other point, so it's gonna be y minus y1, but our y1, if we're using this point, y minus 12 equal to m, the m is 5 over 2, open bracket, x minus, so it's 5 over 3, the gradient, x minus 4. Then we because we want the x-intercept, we are going to substitute y equal to 0 here. So we're going to be left with minus 12 being equal to 5 over 3 x minus 4. We divide both sides by 5 over 3. We divide here by 5 over 3. Simply, we are going to get a negative 36 over 5 being equal to x minus 4. When we bring this here, our x is gonna be equal to, we take it minus 36 over 5 plus 4. When you simplify that on your calculator, the x is equal to minus 16 over 5. Then you eventually write the coordinates of E. It's minus 16 over 5, x coordinate, y coordinate being 0. That becomes the answer. Then the next question, that's 4.3. There. That's 4.3. So to get 4.3, they are saying determine the size of alpha. Here is the alpha. Determine the size of alpha. Round off your answer to the nearest. Alpha is the angle of inclination of E. So angle of inclination is equal to tan inverse gradient. So it means the alpha must be equal to tan inverse this gradient tan inverse gradient, which is going to give us the gradient. We found it to be 5 over 3. So it's tan inverse 5 over 3. They say it as a whole number. You just have to punch that on your calculator. So if it's punched on the calculator, tan inverse 5 over 3. Second function, tan 5 over 3. We are getting 59.0, but 0.0 what? But the question is saying here the answer is a whole number. So it means the alpha is equal to 59 degrees because we are getting 59.0. So here we are getting 59 degrees. Alternatively, it was possible that since we have the x coordinate here is minus 16 over 5, we're supposed to also get the y-intercept depending on how you had done the equation. So let us try to do it. If you have done your equation in 4.2 using y equal to mx plus c, it means it was going to be y equal to the gradient 5 over 3 x plus c. But we choose any point. So if in case we choose this one, y is 12. In case we have chosen this, oh, it's freezing. In case we have chosen that, so the y is 12 being equal to 5 over 3 times the x, which is 4, plus c. So you are left with c being equal to